Okay, so we're going to start by talking about Unit 5, Proficiency Target 5, and it's the connection between moles and mass or grams. And so we have something called the molar mass, and the molar mass can be found on the periodic table. So we have sodium hydroxide, NaOH, and then I notice that when I'm looking at this, I have one sodium atom, one oxygen atom, and one hydrogen atom. And so I have one sodium atom. So I have my parentheses here, 1 multiplied. Now I'm going to look at the molar mass on the periodic table, and it's 22.990. So 22.990. So I have one sodium atom, and I'm going to add that to one oxygen atom. And so then I look at my periodic table, and I see that the molar mass for oxygen is 15.999. And then I'm going to add that to one hydrogen atom. And I notice that the molar mass is 1.008. Okay, so I'll plug that in to my calculator. So I have 1 times by 22.990 plus 1 times by 15.999 plus 1 times by 1.008. So the molar mass for sodium hydroxide is 39.997 grams per mole. Okay. I'm going to have you do number 2. Now looking at number 3, so if you want, you can hit pause. You can give number 2 a go, and then come back and we're going to look at number 3. So we have Mn2Se7. And so we have 2 atoms of our manganese, and the molar mass is 54.938. Okay, so 2 multiplied by that molar mass plus, and then there's 7 selenium atoms, and they each have a molar mass of 78.971. Okay, so I'll plug that in. Alright, so then we have 662.673 grams per mole. Now it's important to know these numbers because we're going to be putting them in our goalpost here in just a moment. Alright, I want to try one more of these, but one where we have a parentheses. So if I'm looking at number 5, we have 2 aluminum atoms. So I'll take 2 multiplied by the molar mass of aluminum, which is 26.982, and then I'm going to add that to how many sulfur atoms there are. The subscript tells me how many atoms, but if the subscript is outside of a parentheses, it applies to everything in that parentheses. So I have 3 sulfur atoms, and then I'm going to have 3 multiplied by 4, so I'm going to have 12 oxygen atoms. So there's going to be 3 sulfur. Sulfur has a molar mass of 32.06, and then I'm going to add that to 12 oxygen atoms, and oxygen has a molar mass of 15.999. Okay, so I'll run that number. $342.132 grams per mole. Alright, and then I want you to run those other ones on your own and then check with the key. now we're going to be using these molar mass values. So how many grams will 5.5 moles of copper bromide? We can go right from grams to moles of the same item in just a one-step goalpost. So upper left is always what we're starting with. We're starting with 0.500 moles of copper bromide. Moles of copper bromide. So I'm going to take that unit and I'm going to place that down below. And I want to end with grams of copper bromide. Okay, we're going to start training our brains. Whenever you see grams over moles or moles over grams, I want you to start thinking molar mass periodic table. And we have one copper atom and one bromine atom. And so when I look at this, I would go to my periodic table and I have one copper atom. Let's see if I can get this all in the same shot. Yeah. Okay, so I have one copper atom, so I'm going to take that molar mass of copper, 63.546, and I'm going to add that to one bromine atom, which is 79.904. And that's my molar mass for copper bromide. That's how many grams there are in 1 mole. So when you get those numbers on the periodic table, it's always going to be how many grams. So it's always going to go with grams. It's how many grams in 1 mole. Okay, so moles of copper bromide cancel, and we're left with grams of copper bromide. And now I'm going to run this goalpost. I'm going to run these numbers. So we're going to take the top of the fraction, 0.5, times by that molar mass, and then close parentheses, and then divide by what's on the bottom of the fraction, but this time it's just 1 that's on the bottom. So I have 71.725 grams of copper bromide. Put a box around that because that's a reasonable answer for copper bromide. Okay, let's see. So, looking at the assignment that we were doing. Okay. Again, you took pictures, or you should have this answer key, and I want you to check your work with that answer key. So you're going to give number 8 a go, and then let's talk about number 9. So we are identifying where we're beginning and where we're, and actually this one's really similar. Let's skip down to number 10. How many moles are there in 68 grams of copper hydroxide? So I'm starting with grams and I want to end with moles, so it's a little bit different than the last one we did. So upper left, we're starting with 68 grams of copper hydroxide, CuOH2. And I'm going to take that unit and I'm going to place it diagonally down below. Grams of copper hydroxide. And I want to end with moles of copper hydroxide. And whenever I see grams over moles or moles over grams, grams over moles, moles over grams, I'm thinking periodic table, molar mass. And we have one copper atom, 2 oxygen atoms, and 2 hydrogens, because it's outside of that parentheses. Okay, so I'm going to take the molar mass of one copper atom, 63.546, and I'm going to add that to the molar mass of 2 oxygen. So oxygen, 15.999. So 2 times by 15.999 plus the molar mass of 2 hydrogen. So 2 multiplied by 1.008. And that's how many grams per mole. Okay. So this is 97.56. Notice I'm writing it with the grams, not in the numerator, in the denominator, because that's where the grams are. That's how many grams in 1 mole. Grams of copper hydroxide cancels, and I'm left with moles of copper hydroxide. So now let's calculate this. So on the top of our fraction, we have 68 multiplied by 1 divided by that molar mass. And so we will end with 0.697 moles of copper hydroxide. Okay. I'm looking ahead, just seeing if there's any that are drastically different. On number 15, notice that it's in kilograms, and all those values on the periodic table, it's not kilograms, it's grams. And for every kilogram, 1 kilogram is 1,000 grams. So we're going to change that. We're going to, instead of saying 1.25 kilograms, we're going to say 1,250 grams. And that's what I would use. So maybe we'll continue to do number 15 together. Sulfuric acid is found in the battery of your car. How many moles of this acid are there if we have 1,250 grams? So upper left is what we're starting with, 1,250 grams of sulfuric acid. And we want to end with moles, so I'm going to put grams of sulfuric acid in the bottom right. And we're going to end with moles of this acid. Okay, I'm training my brain. I'm seeing that it's moles over grams or grams over moles, so I'm thinking periodic table. So there's 2 hydrogens, 1 sulfur, and 4 oxygens. So looking at my periodic table, I have 2 hydrogens, so 2 multiplied by 1.008, plus 1 sulfur, 32.06, yep, and then 4 oxygens, so 4 multiplied by 15.999. That's my molar mass, and I'm always putting that with grams. So there's 98.072 grams in 1 mole. So grams of H2SO4 cancels, and I'm left with moles of H2SO4. Okay, plugging it in, I have 1,250 times by 1 divided by the molar mass. So I'm going to end with 12.74, let's round, we'll say 12.746 moles of sulfuric acid. All right. Now, notice number 19, it says that it's a 2-step problem because we're not starting with moles, we're starting with molecules. So I have I'm ending with molecules. How many molecules are there in 70 grams of SO2 sulfur dioxide? Okay, so let's think about this. Neither one of those is moles, but I'm going to have to travel through moles to get there, because I'm starting with grams of SO2, and there's no direct connection from grams to molecules, but I do know how to go from grams to moles, and I know how to go from moles to molecules. That one's going to be Avogadro's number. And so this is how I'm going to set up my goalpost. I'm going to go grams of SO2 to moles of SO2 to molecules of SO2. And then those units, we're going to place them diagonally down below. So grams of SO2, and then this one's going to go diagonally down below, moles of SO2. Starting with 70 grams. Okay, we've been training our brains. We know that when we see moles over grams or grams over moles, we're thinking periodic table. Then I'm going to get that molar mass. So there was 1 sulfur and there was 2 oxygen. And I'm going to put this number with the grams. There's 64.058 grams in 1 mole of the sulfur dioxide. Now I see molecules. This is an item. So remember we talked about how if we see atoms or molecules or compounds or ions, that's going to be Avogadro's number, 6.02 times 10 to the 23rd. And that's always going to be 1 mole of those things. So grams of sulfur dioxide cancels, moles of sulfur dioxide cancels, and we're left with molecules of sulfur dioxide. Let's plug this into our calculator. So on the top of my fraction, I open my parentheses, I do 70 times by 1 times by 6.02 times 10 to the 23rd, close parentheses, divided by, and then open up parentheses, and that was molar mass multiplied by 1. Okay. Close parentheses, and so we got 6.578 times 10 to the 23rd, because remember how the E means times 10 to the 23rd? That's a really big number, but it's okay because we're talking about teeny tiny molecules. So it makes sense that we would need a lot of really teeny tiny molecules. Okay, number 20 is also a 2-step, so I want you to give that a go. Okay, so let's see. I think you can, let's do maybe 1 like that. Yeah. So the last few are really similar, so let's maybe do number 22 together, and then you'll be able to do the other ones. So water has a molecular formula of H2O. I have 50 grams of water. So if we have 50 grams of this water, and we want to know how many moles of water. Okay, so upper left, I have 50 grams of water, and I want to know how many moles of water. And when we see grams over moles or moles over grams, we're thinking, periodic table. 1 oxygen and 2 hydrogens. And I'll add that all together, and I'll get 18.015, and I'm always putting that with the grams. So that's how many grams in 1 mole. So I'll plug that in, 50 divided by the 18.015, and so we get 2.775 moles of water. Okay, now if we want molecules instead, then we're going to try this with a 2-step. So we are going to go grams of H2O to moles of H2O. And then once we're in moles of H2O, then we'll go to molecules of H2O. So we have grams of H2O, moles of H2O, just following the map that I made, molecules of H2O, and then we take the prior unit and we place it diagonally down below. So grams of H2O, moles of H2O. We're starting with 50 grams. Okay, grams over moles, that's molar mass. So it's 18.015 molecules. That's one of our items. So that's where Avogadro's number goes. And that will always be over 1. So grams cancels, moles cancels. Okay, so running this in my calculator, open parentheses 50 multiplied by 6.02 times 10 to the 23rd, close parentheses divided by, open parentheses 18.015, close parentheses, 1.671 times 10 to the 24th molecules of H2O. Okay, that's those examples. I think you'll be able to do the problems that are really similar to that. And then in the next video, we'll look at proficiency target 6, because we stopped renumbering. So proficiency target 6. That will be our next video.